Thanks for joining us. This is the Global Mapper webcast for the month of December. I'm Katrina Schweikert, and I'm here with my colleague David McKittrick.
Thank you, Katrina, and thank you everyone for taking time to stop by with the latest Global Mapper webcast. As you can see, the slide on the screen gives you an indication as to what we're going to be covering today. Question asked, do you think, or so you think you know Global Mapper? We're going to spend the next hour or so introducing you to what we would think to be some of the features and functions of the application that you may not be familiar with, you may not have used. So we're going to reveal some of what we would probably define as the hidden gems in the application. And we were writing up the notes for this presentation. The list of features actually extended beyond what we have time for today. So we may actually revisit this topic and maybe perhaps next month do a second Part two, yes, the return of perhaps. So before we get started today, a couple of housekeeping issues to cover.
So this is a pre-recorded session, but you can always reach us at geohelp@bluemarblegeo.com. So that address should be in the notes if you're watching this on YouTube.
Yeah, it's in the description right below. We'll put a link right in there.
Yep, and it'll also be at the end of the presentation.
Yeah, so those of you who have in the past attended our live webinars, we do give you the opportunity to ask questions in real time. We try to answer them in real time. Unfortunately, that's not an option today. So let's get to our agenda for today. Again, as I mentioned, there's probably way more content for this particular topic than can be fit into a single session. So we will try to come up with, as Katrina mentioned, part two. We're going to begin this session, though, by going through a workflow that we've done a few times, and certainly we do it in our training classes, and we've done it in some of our online demonstrations as well. We're going to use a little bit different data today. We're going to go through an exercise. We're going to vectorize or extract vector features from a raster layer. And we'll introduce a couple of additional peripheral components of the software as we go through this workflow. We're going to go into another raster tool. We're going to talk about blending. Katrina's going to show us a very interesting tool for working with overlapping raster layers and how you can make them essentially play together. We will create a Voronoi diagram. That's actually what you're looking at on the left side of the slide here. It's a very interesting illustration or visualization of data derived from points. And we'll take a look at that tool. There's a lot of different applications. This particular example we're going to use is based on some weather data, some rainfall data. So we'll go through that process. This is going to follow on from the initial creation of those Voronoi polygons. We're going to generate a thematic map and, again, assign some colors to the polygons that we create. This is one that we get asked about a lot, the idea of optimizing labels. There is no real easy way to manage labels. Labeling, almost without exception, does require some hands-on or some manual intervention. I'm going to show you a little trick that you can employ to position labels and to manage labels very efficiently and very effectively. So this is not something you'll find in the documentation. This is using some of the capabilities of the software in a very creative way. We will then generate a quiver plot. Again, we've used this one in many of our demonstrations. The idea of visualizing point data, referencing or reflecting some of the inherent variables, specifically direction and magnitude. Now, we're going to use this function to create a map that visualizes and represents slopes, not only the steepness of the slopes, but also the angle or bearing of the slope as well. So, again, those of you who have been in my training classes may have seen us do an exercise along these lines. I'm going to do something similar today. Finally, we will talk about perpendicular profiling, something that was introduced fairly recently, specifically for working with point cloud data, but we're going to use it today with some terrain data. We're going to create a series of perpendicular profiles going through the terrain and looking at sequential cross-sectional views. Now, as you will find as we go through each of these workflows, we will introduce other functions, other features of the software. In order to perform certain workflows, we'll have to bring in things like the digitizer and other tools, and hopefully along the way, you'll get a chance to learn some of the additional functionality that you may not be familiar with. Okay, so for the first exercise, we're going to run through a workflow where we're going to extract some vector features from a raster layer. Now, specifically in this case, our objective is going to be to create a linear feature, a line feature. And we're going to begin this process by, first of all, previewing the data that this line is going to be derived from. There's a couple of workflows that we'll bypass. Getting that data into the application, getting that file into the application requires rectification. We've already done that, but we'll show you how that process would have worked. And then we'll go through the procedure where we identify apply the linear feature, ultimately will generate some polygons, and from those polygons, or from that polygon, will generate a line. So on the screen you'll see the actual file that we're going to be working with, and obviously you can see in this case it's got some recognizable features. What I'm specifically going to be interested in this workflow is this red line. Now, obviously in this format it's just pixels. There's nothing that distinguishes this feature from any of the surrounding features. Again, the objective of this exercise is to create a linear feature that essentially follows this red pipeline.
So this was a scanned map, is that right?
This is a scanned map, yeah. There's absolutely no geographic intelligence embedded in here. This is just literally a JPEG, and it was a scan map, or it is a scan map, exactly right. So I'm going to close this window. And the only reference data that we have to begin with is, as you can see, a map of the US. In order to perform the first stage of this process, we need to apply geographic intelligence to that image. And again, in the interest of time today, I'm not actually going to perform this procedure. If you want to see the step-by-step process that I'm going to show you the end result of, you can go back to some of our other presentations and you'll see how that rectification process works. But I'm going to right click just to show you the dialog box. Some of the menu items have moved around a little bit in version 18 of Global Mapper. Those of you who are still using an older version, you may find this is in a different position, but here in version 18 our rectify tool is right here. Now this is a tool that allows you to essentially establish control points, or what I like to define as applying geographic intelligence to the image.
So this will also come up when you first load the JPEG, right?
Absolutely right. If I had just simply loaded the JPEG, it would have prompted me, given that it would have not recognized any geographic intelligence, it would have prompted me to apply that before it actually rendered on the map. I've already done this. You can even see the control points that I recognized. In this case, it was fairly easy because the map that we're using had the very clear county boundaries, so I just selected some very distinct boundaries, placed just 4 or 5 points around the edge, and you can see the corresponding control points that I placed on the US map as well. Again, in the interest of time, we're not going to go through that process, but I ended up with a list of control points. I'm going to cancel, and this is, we've used this analogy quite a lot. This is a little bit like a cooking show. This is now the finished product. This is that map that we previewed, now correctly positioned geographically. We have a reference framework, if you like, that will allow us to extract this linear feature in the correct geographic location. I'll just zoom in just a little closer. You can see some of the text is a little bit pixelated. We'll zoom in close and it gets to an optimal position as far as the visibility is concerned. So the way this process works is we're going to essentially extract area features. Now, if you remember, my objective is to create a line, so I have to first create an area, and as you'll see in the second part of this workflow, I'm going to transform that area, that polygon, into a single line feature. The way I start this process is by selecting the layer in the Overlay Control Center, right-clicking, and I'm going to go to the line item that allows me to create area features from equal values in our selected layer. Now in this case, equal values refers to colors. This tool can also be used for elevation extraction. If you're working with terrain data and you want to extract areas that match a particular terrain threshold, you can use this same function, or indeed you can use it for slope extraction as well. Go ahead and select that option, and this is where I tell the application which colors that I want to extract. And you could perform this in such a way that it actually extracts multiple colors concurrently, but in my case I'm only interested in this red pipeline, so I'm going to go all the way to the bottom, and I'm only creating areas for a selected color. This obviously prompts me then to select the color, and the color I want to choose is this red color. I can choose it manually. 25500 would be the corresponding RGB. We'll click OK, and I'm all set to go with this, but I want to show you as well where if there's some ambiguity as far as the colors, and in fact if we did zoom in a little closer to this pipeline, you would see some of the pixels are a slight variation on red. I may want to expand this threshold slightly to make sure what I capture actually encompasses the entire extent of this red line, even those that are not that pure red color that I've selected. In order to do that, I can define a match distance. I'm going to expand this by a factor of 50. Basically, this is a value that can go as high as 256. If I specify 256, it would basically mean that every pixel in the image would be a matching color. And obviously that would not be that useful in this case. So I'm going to keep this at 50. I think everything else here is fine. We'll click OK. and it will run through the process of essentially vectorizing that line. Now, very difficult to see any results of that process. The easiest way to see how that process worked is to turn off the original JPEG. And now you can see a vector form of that line. It is extracted matching colors, and if I zoom in close, you'll see it did exactly what I wanted it to do. It matched exactly right down to the pixel level. Well, that pipeline is now extracted in vector form. Let me get my zoom and go out just a little bit, and we can see it a little more clearly. Now, before I initiate the process of transforming this polygon, this very long, thin polygon, into a line, there's a couple of edits I need to perform to this data. Let me zoom out a little further yet, because you will notice as part of this process, I do have a couple of outliers here. Again, based on the original data, there were a couple of additional pipeline segments here. I'm not interested in those in this case. So I'm going to do a very simple edit to begin with. I'm going to select these outliers, and I'm going to delete them. I'm just simply going to choose my digitizer tool, drag a box around them, and I'm going to hit the delete key on my keyboard. Actually, I'll show you another option here. We can go right to right-click and delete, and it removes those from display on the map. We can now see that, I think it's a single feature actually, has now been deleted.
So another hidden feature here that you're using that might be worth mentioning is you've made your counties so they're not selectable.
That's exactly right. And the visual cue, visual indication is that the layer description in the Overlay Control Center is red. That's a checkbox option right here, where it is on by default, allow feature selection from this layer. In this particular example, simply because I wanted that base map only for visual reference, I didn't want to have to be able to interact with it, I unchecked it. So good call on that one, Katrina. Yes, we've turned off that layer for selection purposes, allowing me to select just the features from the layer that I just created. So zooming in a little closer here, I'm going to I'll just grab my zoom tool and just zoom all the way in here. The consequence of the process that we went through creates this pixelated line. We're going to have to address that first. Before we create our line feature, I'm going to select this polygon. I'm going to perform a couple of different procedures. Both are initiated from a right-click, the right-click menu. There's a couple of ways to get to these. I'm going to go to vertex editing, and you'll see an option to smooth these lines. And this can be applied in many, many different situations where you've got a line or perhaps a contour line that's very angular and you want to make it a little more aesthetically pleasing. You can initiate a smoothing process that you may have noticed a slight smoothing of the lines, essentially inserts vertices to create more smooth angles rather than those pointed angles. Now, having done that once, if I want to perform the same process again, I don't have to go back to that right-click menu again. I can go to my recently used tools list, and you'll see smooth is now noted here. So rather than having to find a tool that you use repeatedly, you can use this drop-down list and just simply click the adjacent star button, or Control-Enter is the keyboard shortcut. And you'll see the lines on the screen every time I click are being smoothed slightly more. So it's creating, again, a little more of a smooth polygon. The other thing I need to do with this elongated polygon is to simplify it, because the next step I'm going to actually create what's called a skeleton. I'm going to create a line that's in the middle of the line, in the middle of that line segment. So in order for this to work, I need to remove the vertices which are not necessary. So I'm going to again go to my right click menu, vertex editing. Previously I chose simplify, or chose smooth, I'm sorry. Now I'm going to choose simplify. And this was going to prompt me with a dialog box that lets me establish a horizontal threshold within which non-required vertices will be removed. Now you will see no difference in the display of the line. This is essentially removing redundancy in the line. I'll click OK with that 50-meter threshold established. I don't need to worry about the vertical threshold, by the way. And we'll click OK. And a slight change on the line, but not a lot. But as a consequence, I've significantly reduced the number of vertices, making the final step in my process a much, much more smooth one. It processes a lot, much faster. So, how do I get from a polygon to a line? This is the key part of this workflow. Select the line once again with my digitizer. Once again, it's a right-click option. We're going to go to our advanced feature creation options. And again, this is a function that allows us to derive new features from existing data. Depending on what you've selected, you'll be able to, for instance, add points along a line, or create lines from a series of points, or create areas from a series of lines. There's a lot of different options are available based on a selection. What I want to do specifically is create what are called skeleton lines. And the way I often describe this, it's almost like a buffer in reverse. When we do a buffering exercise, we start with, for instance, a line, and we'll create a polygon or an area that extends outwards from that line. In this situation, we're doing the opposite. We're starting with a polygon, and we're defining what that center line would be, or that skeleton line, if you like. Very simple process. We're creating a new line, so we have the option to give it a name, assign it to a particular layer, give it whatever characteristics we want. We may want to add the attributes of that feature at this stage. I'm simply going to click OK, and it's now going to go through the process of generating that skeleton line. Now, in order to see this, obviously, we need to turn a few things off. I'm going to turn my pipeline areas off. And now you can see that line has been created. Let me again use my zoom tool, zoom out just a little bit, and we can see now extending for the extent of the original line on that SCAD map, we now have what appears to be a line feature. We're not quite done yet, because there's one more thing that we need to address. As part of this process, the way the Global Mapper created these line segments, it did this based on individual segments. So you can see it's maybe not too clear, but when I selected the line, it's a very small section of the line that's selected here. Each of these is its own section. Very, very simple to address that. I'm going to use my zoom tool once again, and I'm going to select the entire extent of the line. I can do this a couple of ways. I can simply use the digitizer and drag a box around the extent, probably the easiest way. Or if you're dealing with a layer that maybe intersects some other features you do not want to select, you can right-click on that layer and select all. That will essentially perform the same function. With these features selected, I'm now going to combine them into a single line segment, or a single line feature. Once again, right-click. This time we're going to crop, combine, split, and we're going to combine these selected line features.
So this one has a button as well now, so you can see that from the menu, matching the icon in the toolbar.
Indeed, I'm getting used to these buttons, all these new buttons we have in version 18. Old habits die hard, I guess, when you go to menus. I don't know. When I go to the menus, it also gives me a chance to show some of the other things that are in there as well. So this value basically is a distance value, a threshold value in meters. Do we require the lines to be to touch or not? And we're going to give ourselves a little bit of a threshold here. Just glancing down at my notes, I think 10 meters will suffice. With fingers crossed, if I select OK or click OK, it will essentially combine all those lines into one. We can also, using this tool, specify whether or not we want the attributes in each of those segments to match. Now, in our case, there are no attributes, but for instance, if you're dealing with a road network and you want only roads that have a particular name match to actually connect together, you can use this and specify which attributes need to match. Not relevant in this case. We'll simply click OK, and hopefully at the end of that process, we end up with one long line segment, as confirmed in my overlay control center, where previously there was 800, I think. I'll drag this across just a little bit. 869 individual segments have been combined into one. The original segments have been deleted. And if we go back to where we started with the JPEG, we can now zoom in. I'll just grab my zoom tool, and we can now see where that line that I created, deselect it so it might be a little easier to see, now follows very accurately the path of that line feature, or that the image. So again, multiple steps in this process, starting with rectification, automatically digitizing through the extraction process, and then from that that polygon, that elongated polygon, deriving a single line segment. Okay, so the next workflow we're going to take a look at, different raster workflow. We're going to deal with a couple of different raster layers. One specifically is going to be a terrain layer. The other is going to be a USGS 1 to 24,000 quad map, a standard US topographic map. And we're going to play with some of the settings that allow you to work with both of those layers concurrently. We're essentially going to blend them together. There's a couple of tools in there. We can talk a little bit about transparency perhaps as well. You can adjust transparency in either or both layers. And maybe, again, a few other things along the way dealing with some of those raster processes.
Okay, so we have loaded, as David mentioned, 2 layers here. So my top layer here is a USGS topo quad. So let's zoom out a little bit so we can sort of see the full extent of this. And then I also have some elevation data underneath. And I'll just mention here that we do have our layer order in our control center here showing so that the layer on top is top on the list. That is not the default setting. This is a new option in 18. So if I right click on current workspace, we have the reverse order here. So that's kind of the way that a lot of table of contents type things work. So the top layer is the thing that we see on top on the map. That is comfortable for a lot of GIS users, so we did add that option. The standard for Global Mapper has been the last thing on the list draws on top. So different options for how you want to order your overlay control center. Okay, so the first thing that we might want to do here is to get rid of this border around this topo map here. So we've got this margin from this original file, so this was probably an image or maybe a PDF that we've imported here. So we have a quick option here that's going to let us crop out this border. So I'm going to right click on my layer here and go to the options. So this is the topo map layer that we're looking at. And I'm going to head over to the cropping tab. And what we want here is automatically crop color. So we don't need to specify the polygon here. We might not want to go in here and exactly draw the boundary here, and we might want seamless boundaries between adjacent topo quads. So this nice cropping option is going to automatically clip right down to the boundary of that map frame. So we'll go ahead and do that. So now we've got nice seamless data here if we had other topo quads adjacent to this one. But what we wanted to talk about here was blending these 2 layers together. So at this point, I'm just seeing the topmost layer. So one thing that I might want to do as a kind of a first basic would be to apply some transparency to this top layer. So again, we want to go to the layer options. So either right clicking, or you can also double click on the layer to get right to the options. So here's my transparency setting. So if I want to apply a little bit of transparency, I'm just going to start to make this a little bit see-through so we see the terrain through this data.
Yeah, it's just while Katrina's doing this, this in many situations is probably not an ideal solution, because obviously a consequence of applying transparency is you're losing a certain amount of the color intensity of that uppermost layer. Obviously, in order to see what's underneath, you're kind of scaling back or paring back the color intensity.
So that would be one option. Let's put that all the way back up to opaque. So now we have nice bold colors here. Another option might be making a particular color transparent. So I'll just do that quickly. So maybe I want to just cut out all the white areas because that's just background. This one's a palette image, so it's showing me my palette. And I'm just going to quickly cut out my white areas. So that would be another way that I might blend these 2 layers together. I'll turn that one off. You'll see this also has kind of a fuzziness setting, so if this was an RGB image, I could kind of spread out how many color shades I'm including in that.
Okay, comparable to what we did on our last workflow where we established a fuzziness value. Yeah.
Lastly, I want to take a look at this texture map setting here. So we've got terrain data here, and then we also have imagery. So we know in 3D this is going to automatically drape, but this is kind of the 2D version of that. So we want to take the hill shading that's happening underneath and apply that to our elevation data. So in this case, we have shown our elevation layer as a hill shade. So we're applying the daylight shader here.
And let me say as well, by way of setting this up, the daylight shader by default is a blue color. If you select this option from the drop-down in your setup, you'll see it turns your terrain layer a solid blue, accentuating just the hill shade. There's a configuration option. We don't need to go there now, but there's a configuration option to change that color. Obviously, in my case, I changed it to white. So all that we're seeing here is the hill shade pattern.
Yeah. So this texture map setting, actually, it doesn't matter what your shader is. So this one is just going to apply a hill shade. So sort of know that you want to see the terrain relating to this image. So that'll do that automatically. And now it is linked to that layer. So I'm going to go ahead and close that. So I can actually turn off my terrain data here. And this has been kind of burned into this image now. So we could take it away still, but you know, it has integrated with the layer here.
Yeah, and if you export this now, this is basically going to be an export what you see. So you'll get this really nice texture applied to the USGS quad map.
Right, and then we still have pretty dark features here, so we can still see our contour lines really well. We can still read our text here. As opposed to something like transparency, we might lose some of that detail. And the last couple of options that I wanted to mention here are our blending settings. So I'm going to go back into the layer options for my USGS map. And we'll turn off texture mapping. So we also have a number of more advanced blending options here that will apply different effects to the layer here. So I'm going to choose this first one, multiply. So this is actually pretty much the same thing as the texture map. In this case, my shader is going to matter. So we'll see the same result because we already have the daylight shader. But we're essentially going to blend these two layers together. So you can play around with some of these other blending options. So these are different algorithms that are going to keep different parts of the image as it combines those two pixel values that are on top of each other.
Yeah, and in terms of specific to what Katrina has demonstrated here, where we applied the texture both through the texture map and through the blending, if you need to modify the intensity of that, any parameters, any settings you apply to that hill shade pattern, if you go in and say, well, I don't want it quite as dark, or maybe I want the light source to be from a different angle, they would reflect on the hill shape pattern as well. We don't need to change any of those right now, but any configuration you apply to that hill shade will be reflected in this blending process. Do you want to show the water level? I'm going to turn on some water level maybe with the texture map. Yeah, this is an interesting visualization as well.
So I'm going to go back to my layer options here, and we'll go back to the texture map setting. So this should work with multiply as well, but we'll just go to this one here. So the last thing that we might want to do, so we're looking at the imagery on top, but we might want to look at how water might move into this landscape here. So I'm going to go ahead and turn on my water level. So this is going to, for a certain elevation, it's going to fill in the water into my landscape. And then I can also use my toggles here to fill in the water at different heights.
A little bit of extreme flooding event going on here.
Yeah.
So for folks living in coastal areas or working in coastal areas or areas that are prone to flooding, this is a very, very useful visualization tool. What we're doing here is we're blending two layers together to create that texture map, but we're also blending in simulated water because you can obviously still see the features underneath. This is rendered by default as a semi-transparent, and that can be configured to be even more transparent if necessary. So you're seeing basically three different components, potentially three different raster components, but all rendered concurrently on top of each other. So again, for folks in coastal areas or areas prone to flooding, a great visualization for that type of purpose.
So we're seeing that reflected in our terrain shader here in our graph, and we can also go in. I'll just show this configuration very quickly. So if I go into my configuration, vertical options, I can set a specific water level as well. So I might want a particular height that is customizable, and I can change the color, change the opacity, kind of customize that display.
Thank you, Katrina. This next section is an interesting one. This tool, it's essentially a point analysis tool that we're going to be using, the Voronoi diagram, sometimes referred to as Voronoi Thiessen or even just Thiessen diagram. I guess crediting the folks, the two gentlemen who came up with this modeling process. Our raw material in this case is going to be a series of points, and we're going to derive polygons from those points. I often have a hard time describing the procedure. There are some technical documents online. If you want to Google this or look on Wikipedia, you can go into some of the inherent math that's underlying this procedure. Basically what we're doing is we're creating a series of abutting polygons that define the area of influence of a given point. And again, if you look on the left side of the screen, you'll see what we're ultimately going to get to in this process, starting with a series of points, ending up with abutting polygons. Okay, so as I said during the introduction, we're going to take a look at one specific area. We've got data obviously here that I think is for the entire US. Each of these points, by the way, if I use my feature info tool, is a weather station. I've stripped out a lot of the data, but this is actual data from NOAA, station ID, station name, the elevation, not really concerned about that, total precipitation. This is what we're really going to be concerned with. Obviously, in this case, our data is point specific. We know the weather, the rainfall totals at each of these locations. The intention of this exercise is to attribute that weather information, that precipitation, rainfall, snowfall, whatever it is, to an area. Now, obviously, as we look at the distribution of points, there is a clustering of points in the Willamette Valley area up towards Portland and Eugene, a little bit towards Roseburg down the southern part of the state. Towards the eastern part of the state, the points are a little further apart. So what we're going to do is create polygons that are going to be based on the assumption that the rainfall total that's attributed to a point is actually distributed over that area. In other words, rain doesn't just fall at one location. The representative data that is attributed to a single location, we will assume represents an area, and we're going to map the extent of influence of each of these points. Now, I'm going to limit this, as I said, to the extent of the state of Oregon. So first thing I'm going to do is select that boundary. Let me drag a box. There we go. Selected the boundary of the state. When I perform this analysis, we will limit its extent to just the boundaries of the state. The process is initiated from the analysis menu. Towards the bottom, create Voronoi diagram from point features. Not very many options here. It's a fairly simple process. We're going to create a new layer. It's going to be a vector layer, a polygon layer specifically, and you can define a name. It did remember that I have performed this exercise in the past and remembered the name I gave previously. Saves me having to type it this time. We can create lines or polygons. I think most cases you're going to want to create polygons, so we'll leave that as is. We can draw a boundary. Essentially, when we get to the edge of our area of analysis, we'll want to close off each of the polygons. So we will want to make sure we draw a boundary in there, and we want to define the bounds. In this case, this is our common geographic extent limiting dialog box, if you like, where we can crop to something that's selected. In that case, it's the boundary of the state. We'll click OK. And everything else is as is. We don't need to expand our analysis beyond the bounds. Everything else here should be fine. And this is going to happen very quickly. We click OK. And when it completes, we have now created a series of polygons. Katrina and I were chatting offline. It's very difficult sometimes to describe this process, how it works. The easiest way is just to show it. And here we can see the results. If I zoom into a particular area, let's say this point, the influence of this point extends to the extent of this polygon. In other words, if I'm standing right where my cursor is right now, the closest weather station, the closest precipitation measurement location is right here. We're going to assume that the precipitation falling at this area is derived or based on what we measured here, and the same is true throughout the state. Here's an interesting situation where we have 2 points that are very close together, and obviously the dividing line between those two just basically intersects the halfway line between those 2 points. So, if I was standing at the intersection of 3 or more polygons, for instance, again, right where my cursor is, I am equidistant from this point and this point and this point. So that's the basic modeling process that allows us to attribute data from a point to a polygon. If I use my feature info tool and select one of these polygons, you will now see, oh, I think I've still got my outline. I'll uncheck the state boundary, and choosing the polygon, I have exactly the same data that was attributed to the point, now associated with a polygon. Now, in our next exercise, we're going to visualize that data.
So this is useful for a lot of different analysis, right? So we've basically got like a service area or a territory or anything that kind of varies continuously across space. We could take some kind of measured value at a particular location and find all the nearest locations.
Yeah, exactly. And a comparable procedure is used for things like retail analysis. If you're setting up a retail establishment, you want to see the areas of extent, school zones, things like that. How far do the kids, what's the catchment area for the kids that are going to a school? The example that we have used in the past actually is fire departments. If we have a map indicating a location of the fire departments, how much coverage area does each one of those fire departments have to service? And obviously we're just taking into account the geographic parameters, not drivability or anything like that. That's not part of this analysis. It's simply a visualization tool in that context. So following on from that first step in this process, I guess, we're going to apply colors. And again, we're cheating a little bit here because we're looking at the end result on the slide. But Katrina's going to go through the process whereby you can apply colors to features in a layer that reflect some of the attributes or specific attributes or variables within that attribute table. We've used this workflow in many different situations for just simply differentiating objects that share a common value. Or perhaps providing a visualization of a range of values. In this case, it's going to be the latter because we've got obviously numeric values of rainfall totals. Katrina's going to go through the process where we'll apply colors to reflect those numbers.
Okay, so we've got the same data set loaded here. So this is what we just created, the Voronoi diagram. So each of my polygons here has some precipitation values associated with it. I'm actually going to go ahead and turn off the weather stations here. So what we want to create is a color scheme here where we can visually see these precipitation values. So I'm going to apply some thematic mapping to my Oregon precipitation layer. So I want to do this again from the layer options. So I can right click and go to options, or I can double click on my layer name. And we're going to take a look at the area styles tab. So obviously this is area features. You're going to see a similar tab for each of our different vector data types. So lines or points will have a similar option here. And in this case, so right now we're using a default classification. So we have a feature type that we're probably using for just kind of generic unknown features.
I think it's unknown area types. So when you generated those, we didn't have any, we didn't specify the feature type. So and this will be true for a lot of the data formats you import. It will be black outlined unfilled polygons. So technically what we define as unknown area types in this case.
So in this case, we want to style these based on an attribute. So I'm going to go ahead and choose that option. And the value that we're interested in here is the total precipitation. So we could enter specific values here. What I want to actually have it do is pick up on the values that already exist in my data set. So I've got a range of precipitation values here. I just want it to give me some information about that range. So first it's going to ask me to define a base style here. So I want a solid fill. Pick a sort of a green, some kind of green shade here. And I want to make sure that's a solid fill here. So I'm going to vary the fill color here. So I'm just going to keep the border as it is, and then it'll just stay the same. If I instead did no fill, and I chose a particular border style, it would vary the border. But because I have a fill turned on, it's just going to vary the fill. So this is a numeric value. So it is going to give me some statistics about my numbers in my table here. So it's going to give me the minimum, the maximum, and some information about the values in between. So yes, I do want it to do that. And
this dialog box, by the way, will also appear if the layer that we had been applying the colors to had recurring instances of a particular value. Let's say regions, maybe there's 5 or 6 regions within Oregon. The same dialog box or a similar dialog box will be displayed where it will automatically create or apply the color to each of those collective groups, if you like. So it simplifies this process a lot.
So I don't want a different color for every single number. In this case, I want to sort of represent the range using my different shades. So I'm going to say yes. So it's given me some different statistics here. So I've got a minimum value here of about 8 and a maximum value of about 122. And I've also got some information about how things fall in the middle or within 2 standard deviations. So this is going to give me some numbers if I wanted to build some classification here. I could use those values. I just want to go from the minimum to the maximum here. So I'm going to go ahead and delete these ones in the middle.
And it should be noted that the way this process works, it does assign quite literally random colors. And in this case, obviously, these random colors are virtually identical. We've got variations on the shade of green. You're not locked into these colors at all, as Katrina is showing you now.
Yep.
There is an option to specify whatever color values you want.
So we're working with precipitation here. So I think I'm going to do some blues, actually. So light precipitation, maybe a light blue. And heavy precipitation, we might want a dark blue.
And it is worth noting that while we've defined 2 specific values, that checkbox or the cursor is located is an important one, because Obviously, in this case, if we applied this right now, we would not, without that checkbox, we would not get any color ranges whatsoever. It would be solid colors, variations on either that light color or dark color. With the checkbox applied, it will interpolate the colors based on the values. So
this looks a little more purple than blue, but we do get some interesting result here.
And you can create some very ugly maps if you choose. Yeah.
Yep. So, you know, I could have chosen sort of shades of the same hue. That's kind of what I went for here to get a nice thematic map. And then again, we could go, maybe we want actual classified data instead of this kind of continuous range. That would be another option. So I could add some other values here. I'm just going to put a break value in the middle here. So a new value, you know, maybe I want kind of a middle tone here. And this might be at about 50. So maybe I have some meaningful break here.
And where that function is useful is if your distribution of data, obviously we kept the max min value, but perhaps the max value is very much an anomaly where the most of the range is at the lower end. And if that's the case, as Katina demonstrated, you can apply a threshold value at the lower end to accentuate the difference at that end, and obviously not pay as much attention to the scattered maximum values if they're way beyond the normal range.
Yeah, so we can stretch between multiple color shades here, or if I turn off the interpolation, we could also classify our data. So now everything from 8 to 50 is in that light shade. Everything above 50 except for the maximum is the next color. So it's kind of our top break there of our range. So that would be also an option to do classified data.
Right, and very specific hard and fast borders between those values. If that was your approach, you would not do what Katrina had done, which was initialize some values. You would probably define those manually, do the manual threshold.
So that's some basic thematic mapping using some numeric values in our vector data.
And again, there's multiple other applications for that. We could probably spend the entire hour going through the variations on the theme of thematic mapping. If you want some more information on that, again, we've done previous presentations on the various flavors of thematic mapping. So the idea of labeling, or the process of labeling, is something we get asked about a lot, and it's something from a development point of view we're looking at making some significant changes within the application. For the time being, there are some interesting, I'm a little bit tempted to say workarounds or flexible use of tools, I guess might be a more appropriate way of describing it, that allows you to apply labels and to manage labels in a way that will give you more control and allow you to specify things like zoom level range for labels, size of the labels, position of the labels, etc. So this is a workflow I've performed. Again, we do it sometimes in our training classes, certainly for some of my presentations, and I've had some follow-up conversations with folks who said, can you write this down for me, because this is something that would be very useful in my workflow. So I want to share this one with you, a little bit of label optimization. So our objective in this exercise is to apply labels to the states in the United States and to address some of the issues that we will encounter if we simply enable the automatic labeling process. Let's go ahead and do that first, just for the purpose of illustration. I've actually temporarily disabled the labels, so they're not appearing. We'll go to the options, just simply going to check the box to draw the labels for this layer. I'll click OK, and we now see the labels. These labels are derived by default based on the centroid of each of these polygons. And you can see a couple of situations where the positioning of the labels just doesn't work. Louisiana is a good example. Louisiana, obviously, if I was a cartographer, we're working in a cartographic environment, I want to move that label so it actually sits probably down here towards New Orleans, a little bit further south. South Carolina is another one. I may want to move South Carolina up. We've obviously got labels derived from polygons that are outliers from the main state. Wisconsin, Michigan, a lot of the islands around Florida. So obviously there are issues that we need to address. The other thing that we will encounter as we zoom, we will notice that, well, because Global Mapper has been set up with what we call a decluttering process, labels will disappear when we get too far. I mean, the option is to display them all, and obviously that's an impractical solution as well, because it'll mean that labels will literally sit on top of other labels. So again, the zoom level will dictate how the labels are displayed. The point size, by the way, the reason this is happening is the point size is being maintained regardless of my zoom level. And again, that is something that we're going to address through this simple little workflow that I'm going to show you. So again, our objective is to give us more control over the label management in this layer. Now, the first thing that I'm going to do is I'm going to replace the labels that are associated with this layer with a distinct point. In other words, I'm going to generate points that correspond with the current position of the labels. In order to do that, I'm first of all going to use my digitizer. I'm going to use the shortcut method I talked about before, where I'm going to right-click and select all the features in this layer. They're now selected with my digitizer. By the way, I should also mention, you may have noted as I've used the digitizer with some of my data, that the representation of the selection is a yellow boundary. This is a configuration option. I'm not going to go there right now, but if you want to change how your version of Global Mapper behaves in terms of what's being selected, you can make that change. I think the default is a hatch pattern. I find this a little more user-friendly to have the boundary highlighted. So it may look a little bit different in your setup. So again, what I want to do is generate a point representing the centroid of each of these states. It's a right-click option. And with all of these right-click options, it doesn't matter where my cursor is located. Given that I have selected features on the map, I simply right-click. I'm going to go to my advanced feature creation options, and I'm going to go to the option to create new points at the centroids of each of these features. Now, again, there's multiple opportunities for you to use this function. In this particular example, we're using this to extract the label and have the labels in their own layer. The couple of options that can apply here, if there are grouped polygons, and unfortunately in this case these are technically not grouped polygons, they're just outlying polygons that are geometrically distinct, and the attribute table is distinct as well, so unfortunately that's not going to combine them in this case, so I'm not going to worry about that first option. The second option is an important one if I want to move the point inside of the polygon from which it's derived. Now this would address issues where perhaps because a feature would be the shape of a crescent, the actual point derived would be in the middle of the crescent. We want to move that per point inside of the area boundary. Now truthfully, in our workflow we can manually override the position when we get to that point, but as a starting point I will make sure this box is checked. And we'll click OK. And immediately we'll see that the states themselves have been deselected. I now have points that are positioned in the geometric centroid of each state, and you can see that each one has a little dot. I think some of my configuration may have changed slightly in terms of position, but the one thing I want to address here is the actual symbology. I don't need a dot. This is just the default appearance. So what I'm going to do is change the feature type for those points from I think it's an unknown point type, to a text type. So with the point still selected, I'm going to right click and I'm going to go to edit. And this is universally going to change the characteristics of everything that's selected, which we know are all of my points. So again, confirming, unknown point feature is the default feature type, which is represented by that little dot. I want to change that to a pre-configured feature type called text. And text is essentially a point feature, but without a symbol. I'll click OK, and those little dots have all disappeared now. Next thing I want to do, because we're replacing the labels from the polygons with labels that are derived from these newly created points, I want to disable the labels from the original layer. So once again, right click, I'll go to options, or double click as Katrina demonstrated earlier. Again, old habits die hard. I'm going to opt not to display the labels for this layer. And this is a layer specific setting. We're not changing anything universally. It's just for this particular layer. Click OK. And we are now left with just the labels that are derived from the points. The font, you will notice, changed, and I'd forgotten I did this. I actually changed some of my configuration. I'll show you how I did that. The default for any of the feature types can be customized. You can change the colors, you can change the font, and that's something I had done. I'll just go there right now and show you where I did that. Configuration dialog box, and these are points, so we're going to go to our point styles, and we're going to look for text. And the default appearance of this feature type can be defined with various settings in here, and in my case specifically with the label font. I had chosen Verdana regular 10 point. You can change this yourself. Anytime you add this feature type to a feature, a point in other words, it will inherit these characteristics. And we'll click OK. Now, we will still have the option to change this on a case-by-case basis, but what we've done is defined a default. The other thing I want to mention before I leave this dialog box is the option you have for creating your own feature types. And if we think specifically in the context of the workflow that I'm following right now, we may want to set up a unique feature type that's specifically called labels. While we have one called text, it's a generic feature type that will essentially remove the symbol. You may want to have a particular style of label that you want to apply certain font to, or certain other text characteristics. In my case, I made the mistake probably of changing the default for this pre-configured feature type. I may have, if I'd been doing this in a more methodical way, actually created a new feature type for this purpose. But we're okay with this for the time being. We'll click OK. And we're back to our map again. So we've at very least at this stage, we've created a situation where the text is no longer directly associated with the polygons that we're used to create. And at the very least, we can uncheck one or other. They're each independent now. I can turn my labels on or off just simply by changing or turning the layer on or off. By the way, I may also want to change the label for this layer. I'm not going to do that right now, but we have the option to change that description. Obviously, calling it labels would make sense. But we're still going to encounter some of the issues that we saw just a couple of minutes ago. I'm going to zoom out and you'll see we're still having a situation where the size of the text is not necessarily going to reflect the extent of what we're trying to label. I'm going to address that one next. The point size that I selected by default was, I believe it was 10 point. And that is true regardless of our zoom level. What I want to do instead is to have this text maintain a specific height relative to the features that it's labeling. And the way that I do that is by actually assigning a ground unit height for each letter, or for the letters in my font, in my label. So I'm going to go back and select all of those features again. Right click, select all. And I'm going to go through a process where I'm going to edit them. Now, as we would expect, the default style is being applied based on the feature type, based on text. It's using what I have pre-configured for all of these features. I'm going to change that. In this particular situation, I want to specify the style. In other words, I'm going to override the defaults. And I can do that by applying a symbol, applying a rotation, and that would be based on the symbol rotation, by the way. We don't have a symbol, so it's not relevant, nor with the symbol size. But I'm going to go straight over here to the font. And I'm going to change the characteristics of the font, again, for this specific layer or this specific set of selected features. Confirming what we know already, Verdana, regular, 10-point type is what was used. I'm going to go to the bottom. I'm going to choose the option to display my labels based on a fixed height. And this will allow me to specify a ground unit measurement. And obviously we're dealing with letters that are going to be very large. If you look at the letter I in Illinois and you correspond that with actual ground units, you're going to put a very big value in here. Now thankfully I've done this ahead of time, and hopefully I'm going to put the value in correctly. I'm going to put 50,000 meters, which is about 50 kilometers or about 30 miles or so. So each letter will be 30 miles tall. I'll click OK, and I'll apply that, or click OK on this dialog box. And you can see now I've established a text height that will be maintained regardless of my zoom level. In other words, the text maintains its size throughout the zoom level range. Now, one of the things you will see here is we get to a point where that text just does not display clearly. Perhaps right about this level is maybe where I want to actually display the labels. I can establish a zoom level threshold for these labels. Noting my scale at the bottom of my screen, I'm not sure if you're seeing where my cursor is right down at the bottom, but you'll note my scale here. I'm about a 1 to 1 million scale here. Nice, convenient. That's actually 1 to 10 million, I'm sorry. Well, I'm trying to count the number of characters here. What I want to do is establish that as my zoom level threshold for this new layer that I've created. So what I want to do is specify that zoom level range. And I do that.
This is actually moved to the layer options.
It's layer options, okay.
Yeah.
That's right, we created
so
a tab for it.
So it used to be in the right click, and now we have a new
See,
map
again,
zoom tab.
Old habits die hard. I'm going to have to go back to training, I guess. So basically what we're doing here is defining the zoom level range, and we can do it based on a percent size, based on a pixel size. In my case, I'm going to up just to display the labels below. Again, it looks like about 1 to 10 million. I'm just going to type that as an approximate value. And one more zero there, and we'll apply. Now, as I zoom, Beyond that threshold, the labels will start to appear. Zooming out, obviously they're not relevant when I'm further out. If I'm looking at a regional map, I maybe do not want to have my map cluttered. I may have different labels. I may at this level have a different layer, perhaps labeling the countries, or labeling a region, labeling some other variable. So you can obviously set up a situation where multiple layers perform certain functions depending on that zoom level threshold. Now, the final thing that probably the most obvious thing in detaching the labels from the inherent polygons is the ability to move them around and individually edit them. Case in point here, Kentucky. If I select that point, I can simply hit the delete button on my keyboard and it goes away. That was just a little outlier. So I have control over individual labels now in terms of deleting or in terms of moving them around. I'm going to choose Louisiana specifically. And in this case, I want to move the label for Louisiana down so it fits nicely in a wider part of the state. The moving process in Global Mapper can be initiated through a right click, or if you hold the Alt button down on your keyboard. You're not seeing what I'm doing right now, but I've Alt button held down. Now I'm going to select where that point is, and you'll see immediately I'm in move mode. I can simply pick this up and drag it to a new location. So that simplifies the process of moving features around. Just hold the Alt button down while you're selecting. Now, I'm not going to go any further with this process, but you can see what I can do now. Maybe I want to change the size of Mississippi. Maybe I want to change the angle of certain labels. If we move up to the New England area, you can see a lot of the labels are large, but the states themselves are small. I may want to angle New Hampshire, for instance. I'll show you where I could do that. I'm not actually going to do it in the interest of time, but if I could right click and edit, I now have the option to define a rotation angle. So I can specify what the angle of rotation is right here at the bottom. It's 0 by default, in other words, it's horizontal. But if I wanted to angle New Hampshire's label to be aligned with the state, I can specify that angle of rotation here. So you've got complete editing capability over your labels, and you've got the ability to quickly turn them on and turn them off as needed. So this next exercise is going to involve the generation of what's called a quiver plot. A quiver plot is essentially a visualization of points based on direction and magnitude variables. And it's very specific, and there's very obviously very specific applications for this tool. We've used this visualization for visualizing ocean currents. Those of you who have been through my training classes will have gone through that exercise. We also use it for visualizing variations in terrain, specifically on slopes. And that's what we're going to do in this situation. We're going to, first of all, generate some points, going to attribute some elevation variables to those points, and then visualize the characteristics of the slope at each location based on an arrow and based on the size of that arrow, the direction of the arrow indicating the angle of the slope, and the size of the arrow indicating the relative steepness of the slope. So the situation, as you can see on the map, is we've got some terrain data. This is some 10-meter resolution national elevation data set data. I got this from the online source. If you're interested in working with terrain, again, that's a whole other branch of the application. We've had many presentations on working with terrain. Check out our YouTube channel or go to our website and you'll see some of those presentations. My objective in this exercise specifically is to, again, as I said in the introduction, visualize slope. We can see there's a little bit of upland area here, and the analysis I'm going to perform is defined by the extent of this polygon. So as with most of the scenarios, we're going to first use our digitizer to select that, and I'm going to create some points inside of this rectangle. One of the scenarios that we've followed in the past essentially creates random points. There is an option when we right-click, Advanced Feature Creation option, to create randomly distributed points within the selected area. If you're working on something like scientific sampling, this is a very useful tool for that purpose. In this case, in this situation, I'm going to use a slightly different approach because I want to create an array of points that are spaced equally. Now, it's not immediately apparent how you would do that. So again, this is one of these little hidden features in Global Mapper. We're actually going to initiate the gridding tool. Now, typically this is going to be used for generating a grid, an array of abutting or adjacent polygons or lines, as the case may be. And you can use this again for overlaying on a particular area for the purpose of doing some sort of sampling. This is not a lat long grid, by the way. Some people get a little confused with the term grid. They assume it's based on predetermined coordinate values. This is simply an arbitrary grid that in typical situations is going to be defined based on a distance and based on a number of grid tiles that are required. Because I have a rectangle selected, when I initiate this tool where it's previously going to be based on my anchor point, what I'm going to do instead is have it calculate the grids that fill this rectangle. And I'm going to calculate it based on a known distance that falls between. So I'm going to choose this option to calculate the grid counts to fill my rectangle. I'm going to crop to that area feature. This is again our standard geographic extent selection dialog box, or cropping dialog box. And now I can specify the width of each grid tile. In my case, I'm going to keep these at 30 meters. I'm going to change from feet to meters. And 30 meters each time. And to the bottom right of the dialog box is the important selection. The default, if you're using this tool, is to create grid cell areas, or rectangles, essentially. We're going to uncheck that one in this case, and we're actually going to create points. We could create points at the intersection of each of the grid tiles, or at the cell centers. In other words, each 30 by 30 block, basically in the middle, we're going to create an individual point. This is simply going to give us a reference point equally spaced both on the horizontal and vertical axes for the purpose of visualizing the slopes at each of those locations. It will provide labels. I'm going to disable the labels in this case, but this section of the dialog box lets us specify how these features will be labeled, whether they be areas or, in our case, creating points. We'll click OK, and you'll see a fairly close but very regular distribution of points, and again with the labels assigned. Immediately what I'm going to do here with this new layer that I've created, I'm going to disable the labels. We don't really need the labels in this case, and we're left with just the points. The points are still selected by default. Each of these points 30 meters by 30 meters. What I want to do next is apply the elevation values from the underlying terrain to each point location. These points don't have any attributes right now. They were just arbitrarily created using that gridding tool. With them still selected, I'm going to right click on the map and go to my attribute style functions, and there's a couple of options here. One, I can apply the elevation, I can apply the elevations from the terrain there. We want a little bit more information than just the elevation, so we're going to bypass that one. We're going to go down to calculating not only the elevation but also the slope statistics for these features. Because these are points, it's going to add some very basic attributes. If this was an area that I'd selected, it would give me a full report on all of the slope and elevation characteristics within that area.
So I actually see a new one here that I want to mention. We didn't get a chance to show it earlier, but when we were vectorizing our map there, we have this new statistic option that will take the underlying raster and summarize some statistics about that inside of an area. So if you needed to figure out what the most common color was within a given area, that's what this new tool will do.
That's very cool. And also it does say, as do many of these areas, so you could have multiple polygons selected and it would generate attributes summarizing the color statistics for each of those selected areas. Maybe by next month we'll come up with a workflow where we can incorporate that one into the presentation. But for today, we're going to calculate our elevation slope stats. And just a confirmation, would I like to add the unit of measure after each elevation? I say yes, and confirmation that that actually has been performed. And again, we're getting some labels in it. We don't really need our labels. Oh, I think the last dialog box asked if I wanted to add max min, and that's what it's done. It's put a little max and a little min in there. I really didn't need that in this case, but that's fine. We'll keep those. It shows us where the high point and the low point are within the extent of this array. What is important, if I deselect the points now and I select my info tool, is that each of these points now has very precise elevation as well as a slope angle value and a slope direction value. Bearing, in other words, this is a compass bearing indicating at that particular location the slope is at an angle or a bearing of 320 degrees and an angle of 1.5 degrees from the horizontal. What we want to do with that data is to visualize it in sort of a thematic format. We're going to visualize some of the inherent attribution of this data. And as we did with our precipitation scenario, we're going to get to that function by going to the options. We'll double click this in this case. And we'll go to point styles, where previously Katrina showed us area styles, same dialog box, but in this case we're going to derive the visualization of the points. We could perform the same analysis or the same classification, if you like, or define the same range, but we're going to go all the way to the bottom and we're going to use a very specific visualization, a quiver plot, where we're going to generate direction and magnitude direction vector symbols. When we choose this option, we're prompted to choose the attributes that reflect those values. The default, as you'll see, is to define which of our attributes is the U component and which is the V component. Now, this is very specific data that is a magnitude variable along the x-axis and along the y-axis. We don't have that in this point data set, so we're going to ignore this first option, choosing the second, which is to use a known direction and a known magnitude. My direction is my slope direction. That was the attribute we previewed. My magnitude is the slope. The slope is basically the angle of the slope. And we'll click OK. So one other option there I bypassed very quickly was to choose a default symbolization. This is going to be a vector arrow, a black arrow. We could choose a red or green or whatever, but usually it's going to be an arrow. That's the best way to visualize variations in direction and magnitude. Everything else should be fine. We click OK. And now if we zoom in a little closer, probably make it a little easier to see. Let me just use my zoom function. We can see each arrow indicating at that particular point the direction of the slope and the magnitude, and you can see all radiating out from my high point. That's as we would expect. And the size of the arrow indicating the steepness of the slope. And you can see, actually it's interesting, down in this area that looks like a fairly steep river valley. You can see some of these arrows a little bit larger. We can select that one, and we've got a steep slope here. We've got an 18-degree slope along the edge of that valley. Now that these are in vector form, it also gives us the opportunity to interact with the data using some of our standard query functions. So if I open up the search dialog box, which is accessible right here in the toolbar, I can build a query or build a search based on any of these variables. So for instance, if I wanted to find, I'm going to turn off, before I do this, I'm going to turn off my boundary because we've got way more data on here than we need. So again, go back into the dialog box. We're limited now to the arrows, and I'm going to build a query where my slope, let's do is greater than, and what type of value in here? Let's say 20. I'm not sure if there's going to be any results, but this is a number value. Everything else I think should be fine. We'll click a new search. Oops, sorry, no data. Oh, slope direct. No, slope greater than 20. I'm not sure why this didn't work, but
maybe we don't have any really steep slopes. Try 15.
Possibly. I think maybe you're right. Maybe I did pick. I'll do 10. New search. There we go. Thank you. So now we have the slopes that are greater than 10. Now, if I drag this out of the way temporarily, let's actually select all of these, and we'll see those on the map. I'm not going to go any further, but now that these are isolated or highlighted, we can copy them to their own layer, address these particular locations individually. If you're interested in steep slopes, or for that matter, areas that are relatively flat, you want to look at certain areas, perhaps for some sort of engineering project, but you have certain requirements or parameters related to the steepness of the slope. Perhaps in that case, it would be slope values that are less than perhaps 2 degrees. Again, same end results. So multi-steps in that process. Hopefully introduce you to a couple of new tools in there. The idea of generating the points based on our gridding tool, attributing those points with some elevation values, and then visualizing the data to give us a very interesting perspective of slope direction and slope angle. So in this last section, we're going to take a look at a tool that's been in the application for from the earliest versions, a profiling tool, a visualization of a cross-section of the terrain. This tool has also been applied for point cloud data. If you're working with LiDAR, you can use a profile tool in that context as well. Now, some of the changes that have been applied over recent releases of Global Mapper have allowed you to do a lot more with this tool, performing things like vector extraction from point clouds, and as we will see in this workflow, creating perpendicular profiles, the idea of defining a path and then creating cross-sectional views perpendicular to that path. So Katrina's going to show us some of the new features in the profiling tool.
Okay, so we've got a terrain data set loaded again, so the same sort of landscape that we're working with here. So our profile tool has a new icon up here. So we can just draw a basic profile of our terrain here. I'm gonna go ahead and just initiate this from the tool, and we can just take a look at our basic profile. So left click to start my line, then I could add other segments if I wanted to, and then right click to finish it.
And I changed I just realized I changed the background color in this setup. So you think yours is a little bit brighter green if you're doing this in your own
Yeah,
setup.
so we can customize some different things in here. The terrain color here that we're using. So we've got a cross section now of the terrain here. So from the beginning of our line to the end of our line. And we also have some coordinated highlighting happening. So as I'm moving over this graph, I've got an X also moving around on my 2D or top-down map as well.
And that line, by the way, Katrina mentioned this actually before we started, you can also derive that from a pre-existing line. You know, the idea of arbitrarily drawing, maybe in a lot of situations, is not very realistic. Don't want to take the time to do it today, but if you have a drawn line or imported line, you select the line, and it's a right-click option, right-click analysis option for you to generate that profile.
So I'm going to build another profile here, kind of following this river feature. So we're going to take a look at a sort of new tool here that is perpendicular profiling. So instead of just a single cross-section of the terrain, we're going to look at a series of cross-sections following the feature. So my initial view here is just following the river, so you know it might have skipped up on the terrain a little bit, but this is not a very interesting graph here.
It is worth mentioning that the vertical extent of this representation is exaggerated by default to the extent of the window. So if you look at the vertical scale over there, we're only varying by a couple of meters, where the horizontal scale is up to about 12 kilometers. So it looks like there's spikes in here. There really aren't. It's a relatively flat surface.
So I'm going to go into the settings here so that we can look at, instead of along the whole length of the path, we want to look at consecutive cross sections as we move along this path. So in my profile settings here, I want to turn on this perpendicular profiling option. So this section up here. So I'm going to check this option to display a series of profiles perpendicular to path. I can also specify how frequently I want to sample these. So let's take a look at that. So the default here is just to sample 30 times along whatever line feature you throw at this. But we can also do, you know, a specified distance, or we could do it relative to the existing vertices in the line if those were meaningful. So maybe if you're profiling along, you know, a pipeline or a road line or something, those vertices might actually have some meaning in the terrain. So let's do a profile every, we'll do about every 20 meters here. So pretty frequent profiles here. We also need to specify our path length. So this is going to be the length of our profile graph in the end here. So how much of the terrain are we going to cross-section here? So I'm going to make a line about 2 miles long here, and we'll start to see the result here. So we could adjust these settings if we wanted to. But I think this looks to be pretty good here. So what I'm actually looking at now is a cross-section along the terrain here. I'm going to just adjust my 2D map here so you can see. So we've got sort of a T in our line here. So we're looking at a cross-section along the river here.
So, and that the width of that, as you can see, confirmed, although our scale, horizontal scale is kilometers, that's 2 miles across. That's the equivalent of 2 miles across, yeah.
Now, using either the left and right arrow keys on my toolbar here or the left and right arrow keys on my keyboard, I'm going to move along these cross sections. So this is, I think I specified every 50 meters?
20 meters, I think you said.
Okay. So as I move through sections here, I can actually sort of animate along this river line here as I go through the terrain. And you'll notice that my y-axis is actually changing relative to each cross-section. I can change that if I want to as well. So let's go back into the settings quickly here. So if I wanted to clamp my elevation range and my y-axis here, we could just choose some specific values here so that it doesn't keep rescaling. We can also do it as a scale factor relative to the terrain, so that would be another option. So this is going to animate a little bit better here now that we've got a fixed y-axis.
And on the right side, just peeking out from behind the window, you can see the progress of that animation as we move through the terrain, as we move up the river valley. that lateral perspective, that line will move with the animation.
So kind of an interesting visualization there to see this. Another point that I'll make here is this will actually display the water as well. So if we turn this on, I think I have to refresh my graph here, but I can also show some water here. Actually, I just need to increase my water level.
Yeah, maybe close the window and open it back up again, it might work.
Let's show my previous profile. Here we go. So we could also fill in the water there if we wanted to at a particular height. So that's going to show up on the graph as well, and using the same color that we set in the configuration for that water. This can also show vector features that cross the line. So any type of corridor analysis, that type of thing, this is a great tool for that. So we can show line and area features that intersect the path that I'm looking at. We can also, we're seeing the location of my profile line, so the vertices of that are showing up as yellow dots here on the graph, so that's another option as well. So a bunch of other advanced settings to kind of make different profiles here, change the display. This can also show multiple terrain layers, so we could have separate lines if we had multiple terrains loaded, representing those other, maybe a subsurface terrain or something else like that.
Yeah, and as we said, a lot of these tools, a lot of these enhancements were brought into the Global Mapper package, if you like, specifically for working with point cloud data. Some of the things you can do with when you create a profile of some LiDAR data. Obviously, they have applications beyond that, as you can see in this case, with terrain and creating what essentially, as Katrina mentioned, is an animated view of the terrain as you transition. So that's pretty much us out of time for today. We just wanted to, again, as we said in the introduction, give you a kind of a sneak peek, or not a sneak peek, but a little view of the some of the less well-known functions, perhaps tools in Global Mapper that you haven't looked at. I think we will continue this theme. We ran out of time today. We went over our time today. There's a lot of other items on our to-do list, on our notes list. So look out next month. We'll take another look at some of the less well-known features and functions of Global Mapper.
So if you have any questions after watching this presentation, you can reach our technical support team, including myself, at geohelp@bluemarblegeo.com. Any questions about purchasing Global Mapper or other sales questions, there's also our email address for our sales team. And if you don't have a copy of Global Mapper, you can register for a free 2-week trial and go ahead and test out some of this functionality. So there's the link as well to download the product and try it out.
And if you're watching this presentation on YouTube, if you look down at the description below, you'll see some of this information down there as well. So, Katrina, thank you very much for your help today.
Thank you, David.
And we'll look forward to speaking with you next month.